Okay, today we are going to be the fuel through what your module is calling an opposed plunger inlet metering distributor pump. Looking at this particular pump, we see in this area we have your throttle controls for your high and low throttle positions. They're adjustable by these screws. We see a side plate here that when it's removed you can see the timing marks that will indicate that this pump is correctly timed. Of course, the engine would have to be in the proper position. And down here you can see the hydraulic speed advance mechanism. So let's take a look at what's going on inside this pump when it's operating. I'll just flip this over. Okay, so a couple things we need to be aware of to begin with. This pump, the opposed plunger pump, is not very good at drawing up its own fuel, so we usually need a lift or supply pump to supply fuel into this fitting here. The fuel comes inside this end of the housing through this little tiny screen and enters into the vane style transfer pump. And if you can see, while I am operating the rotor, you can see the vanes coming up out of the rotor as they follow the liner, and at the other side, as the vane gets squeezed back into the rotor, the decreasing area creates the transfer pressure. Now, and I'll just try and set this up here so we can see it. Some of the transfer pressure will come and act on the pressure regulating piston. And as we talked about in class, the pressure is speed sensitive, transfer pressure is speed sensitive on this pump, from possibly 25 psi at idle upwards of 125 to 130 psi at maximum RPM. So that pressure is always working on the end of this little piston. And there is a small drain port, or spill if you will, partway up the side of this piston, and when the pressure exceeds what the requirement is for that given speed, this plunger will move and uncover that spill port, and excess pressure will escape back into the inlet side of our transfer pump. There is an orifice here that is always bleeding off a certain amount of fuel, so we are ending up with a little bit of fuel pressure, or the same, I guess, kind of fuel pressure building up on both sides of this to balance this if we were to be at a steady state and speed. Okay, so that is how we get fuel into our transfer pump. The transfer pump is internal to this particular high pressure pump. Once we create transfer pressure, that transfer pressure does a few things. It will enter through a passage into this annular groove. And attached to this annular groove are a couple of things. Up above here, going up into the housing, there is what is known as a calibrated vent wire fitting. And I don't know if we can see that in the back there. It's not very easy to see. Way in the back, that is where the calibrated fitting is. And transfer pressure acts against the calibrated fitting or restricted fitting, and the vent wire gathers up air bubbles and takes the air bubbles, and then they are brought up into the housing. Because it's a restriction, the pressure in the housing is much less than the transfer pressure. The transfer pressure also acts upon our advance piston down at the bottom here. So that transfer pressure comes through that annular groove, through this passage, and some of it's been cut off, and it acts against the end of this piston. So if we were shut off, this spring would have the piston all the way over here into a delayed or retarded timing position. As the engine starts, we begin to build transfer pressure, and as speed increases, transfer pressure increases, so that speed and increase in pressure would force this piston against the spring. And if we look over here at the timing mark, if we can see that, if we look at that timing mark, you can see that as pressure increases, our internal cam ring moves against rotor rotation. So let me just put that roller right on the mark. And if that was at no pressure, when we have full pressure, we have now basically advanced the beginning of injection or advanced the timing of our fuel injection event. Okay, so transfer pressure also acts against our inlet metering valve. This inlet metering valve moves back and forth through actions of the governor and obviously at the request of the operator, whatever he is desiring at that time. Okay, now as this inlet metering valve is moved back and forth, some of the fuel or a quantity of the fuel is metered into this annular groove in this area. The fuel in that annular groove then would jump the gap as the rotor is turning. It would jump the gap. And if you can see down here, there are several slots coinciding with the outlet ports of this high pressure pump. So as the fuel jumps across, it comes up against this delivery valve in this particular one. The delivery valve is around 350 to 500 psi to unseat, so transfer pressure won't do that. The only thing transfer pressure can do is move across and force apart those two plungers with the quantity of fuel that we allowed to bypass the inlet metering valve. As the rotor continues to turn, our transfer ports come out of alignment, or our charging ports come out of alignment. Our plungers start to get forced together. Our rollers and shoes ride up on the internal cam lobe. The plungers are forced together. Fuel is pressurized. It can no longer escape here because nothing is aligned. And as that pressure increases, it easily overcomes the delivery valve pressure, spring pressure, and the residual line pressure. And we've developed an injection pressure that will then, at that point, jump this gap and go out to the particular injector. Now this comprises the pumping element of this particular type of pump. If this was a 6-cylinder pump, one revolution, 360 degrees, would do all 6 injections, which would be 60 degrees apart. And once this is built, that cannot be changed because it is a machined component. Now, one of the last pressures we're going to look at is housing pressure. This housing pressure is in all areas of the housing. It is around 3 psi, give or take. And any air that is entrenched in that fuel comes up and against this little ball and spring here, which maintains that housing pressure, and that escapes back to tank. All parts of this pump are lubed. You can see the 2 cup seals here. They are there to make sure that fuel pressure or housing pressure does not escape out into the engine and cause fuel dilution. Back in this area, there is also another cup seal facing the other way, and that will stop crankcase pressure from entering the pump. Not oil pressure, but crankcase pressure. Sometimes there can be a bleed hole between these 2 cup seals so that you would have a area where the fuel pump might drip to let you know that one of your cup seals is already damaged. Okay, now let's take a look at the governor. The governor on this particular pump works like any other governor, except we have several flyweights instead of just a couple like we may have seen earlier. And what's happening here is when the engine starts, these flyweights want to move out. And when they move out, and I'll just disable the fuel shutoff, when they move out, you can see that it is now influencing this link. And what that's doing is as the flyweights fly out, the link is squeezing back on the spring, the governor spring, which is back in this area, And when it does that, it adjusts our inlet metering valve. And what we know from the governor module, the basic function of a governor is that if the flyweights are moving out, we are moving into a less fuel position because we are compressing the spring. However, conversely, if the flyweights are moving in, like if the engine slows down due to a load, now there is less centrifugal force, and now the spring will start to win, and that would put our engine into a higher fueling position to carry the load or to speed up if that's what the operator wants. One last thing I want to cover is, should the outlet or drain back to tank ever get plugged or kinked, then what happens is the entire insides of this pump will fill up to whatever the transfer pressure is, and since it's transfer pressure essentially that is forcing these plungers apart, they will also hold them into the center, so the pump will do one last injection, and then you'll have equal pressure on equal surfaces, and the engine will stall. Hopefully you're using this as a study guide, and we can discuss any further in class what you might need to understand more about this particular pump's operation. Thank you.